Wrote this as a like 35, 40-minute talk, A, because I can think of few worse things than listening to me talk for an hour in the morning on the second day of a conference, and B, because I deliberately wanted to write it in a way where we don't have to wait for the end for questions, and then just like smash a few in there at the end. So please ask questions throughout, because I deliberately timed the talk so that we've got time for that. So just we won't have to wait for a mic or anything, just raise your hand, ask a question. I'll just repeat it for everyone so we've got it on tape, and yeah, let's just do it. Cool. All right, so I went with the world's longest title for this one, which looks even bigger when actually on the screen there. So hey, we'll just jump in. So my background, hi, I'm Zane Lackey. I've spent my career on different sides of the fence, and this is something that I definitely recommend at any point in your career is really trying things from the other side, because I think it really gives you a great perspective. So I started out on the pen test side and security researcher and fun stuff like that, consultant. So if anyone knew ISEC Partners, which is now part of the British company NCC Group, getting the entire At Stake band back together, slowly one acquisition at a time. Started out there for a while, then went over to Etsy, where I was the first head of security there. And I built and led our 4 different security teams there. So I led our application security group, our infrastructure security, then our security engineering and risk engineering. And now, co-founder, my 2 co-founders and I, spun out of Etsy, and we really took the lessons learned of being one of the first organizations to go through this shift to what we're all now calling DevOps and cloud and agile and CI/CD and everything like that, and co-founded Signal Sciences out of our lessons learned on that to make a product that defends web applications. Cool. So what is this actually about anyway? And I could have made a much more concise title if I had thought about it. This talk is really about lessons learned adapting the kind of principles of the SDLC to the modern DevOps cloud world, right? The principles of the SDLC that we're all familiar with, and I'll get into all of this sort of stuff, but the SDLC is awesome. But it was also, written 10 years ago as kind of a methodology, and that methodology, when you look at it in the waterfall world, makes a ton of sense, but there are certain key pieces of it that have to adapt to the way that we're actually building and delivering software now. Let me ask, I normally hate the raise your hand sort of thing, but I'm curious. How many folks are in an organization where, yeah, you're seeing the shift to, I'm gonna ask 2 questions here. One is, how many folks are in an organization that you're seeing DevOps or Agile or something like that actually being embraced? Yep. Okay, anybody, I want to actually ask the reverse, and don't be ashamed to raise your hand here. How many folks are in an organization that's still totally waterfall? Cool. For the waterfall ones, are you seeing that? Are you seeing kind of the writing on the wall that's headed towards DevOps, or do you think it's going to be, is it kind of staying waterfall? Curious. Anybody? It hasn't changed yet, but it's going? Cool. Okay, so I heard something early in my career about if you give people the conclusions right up front, they get emotionally invested in the talk and actually stay. So this is a great time to just run for the exits if this sounds super boring. But this should actually be cliche alert right here, which is, yeah, security shifts from being this gatekeeper to actually enabling users to be, and development teams and DevOps teams to be secure by default. It's completely cliche at this point, right? But it doesn't make it untrue. This actually is very true, and that's what I'm going to be talking about today. So what has changed for us in the world? Well, I think that there are many things that have changed in the DevOps world. I'm going to kind of distill this down to just a couple, and I'm probably going to miss something as part of that. The first is that change just happens orders of magnitude faster than we've been used to it throughout our career. When I went from ISEC to Etsy, I foolishly did not take any time off in between. So I finished my last consulting gig on a Friday. I started at Etsy on a Monday. And my last consulting gig was at a place that was deploying 2 times a year. And so I handed off the report to, like a pen test report to a place doing 2 times a year. They were going to fix those bugs at best in 6 months, realistically probably in 18 months. And I started at Etsy on a Monday, and they sat me down and said, we deploy to production 20 times a day. And I'm like, okay, well, this is going to get interesting. And I think that this is a rate of change that we're really all seeing today, right? That is not unique to me or to Etsy or anything like that. We're seeing organizations that used to build software and release software on the order of months to even years, going to months, to weeks, to days, to hours. And it's a trend that's only increasing. And when something changes like that at orders of magnitude in the way that we've dealt with it, obviously the way in which we need to think about security there completely changes as well. And I think the big shift here is that the decentralized ownership of development, right? This used to be this journey of dev, and then you kick it over the wall to QA kicks it out to security, it goes back to dev to potentially fix issues, or to mark won't fix, then it goes to the SysOps group, then it journeys through another test system, and then staging, and then pre-prod, and then prod, things like that. What it looks like at first from the security perspective now is that everyone has just completely YOLO'd this and it's dev to straight to production now. The reality is actually much more gray, right? A lot of those steps don't go away, they just change. And I think that the development organization had to learn pieces of that early on that security is now learning, which is that QA doesn't go away. It just becomes part of your development process, and you have nice CI infrastructure now and everything there. So it's not that we don't test our code anymore, it's that we test it in different ways. And it's not kicked over the fence to a different group to handle just that. And yet security is still in this gray area where a lot of our security programs they haven't adapted from that model yet to the newer model, which is that security really needs to enable the development teams here, and I'll talk about that in a second. But the other part here, and I'm not really going to talk about this piece today, is that there's a really large culture shift that goes along with this as well. This is not a big technical problem. Like, you can solve the technical problem bits of this. The culture shift is actually the harder bit. So I've done another talk on that. It's up on SlideShare if you want to see that. But the combination of these two particular things means that security can no longer be outsourced to in that way. It's no longer we kicked it over the wall, we kicked a code drop over the wall to QA, and then we kicked it over the wall to security, and then it comes back. It's that security's whole mission in life is to enable the development teams and the DevOps teams to be security self-sufficient. Like, that's the real goal. And so security can only really become successful if you can enable those teams to be able to do their jobs well and secure by default. And that's a complete shift in the way that we build security teams and the way that we interact with teams. So I figure it's been too long since a highly technical diagram, so I'm going to lay out what this actually looks like when we apply the waterfall models to a modern world. So if you notice here, in the technical model, this is waterfall security methodology applied to DevOps, which is everything just explodes. Cool. So there's I was debating between putting up like a big SDLC graphic here and everything like that. Honestly, I thought it would just be better if we just kind of talk through some of the core components that we typically see of SDLCs, right? And these are ones I've really seen across the industry during consulting and during programs I've built and everything like that, which is you kind of break it down into design review, static analysis, dynamic scanning, pen testing, and kind of feedback, hopefully into that loop. So what pieces of this needs to change? This could obviously be a 50-hour talk if we wanted to go through everything here. What I'm going to do is just focus in on certain key pieces that I think change really significantly in this world. This does not mean, and I want to be very explicit there, this does not mean that you stop doing other pieces or anything like that and that you only focus on these ones I'm talking about. This is just a function of the amount of time that we have today to talk. I think design reviews actually change in a bit. Pen testing, I actually talk about some of the other pieces there. And there are other components of the SDLC here as well. So this is really a function of the time that we have today to talk about key pieces. Okay, so this is actually our agenda for today. So I'm going to just talk through these kind of 5 sections. and then leave with kind of a case study of where we can get to. And again, please jump in with questions throughout. We've got time for all of that. This talk is built for that. All right, static analysis. My personal record on seeing static analysis reports was a 10,000 page report. I'm curious, has anyone beat that? Has anyone seen a longer static analysis report than 10,000 pages? Anyone? I know it's out there, come on. You don't have to admit it's at your company, it's just out there. All right, static analysis is fun. The way in which we've typically done static analysis throughout has been as a really heavyweight process. Right? It's been that we bring in a static analysis tool and we say, okay, we are going to shoehorn this thing into our code base. And we turn it on and we run that, and that 10,000 page report pops out, and we're like, okay, well, we know what we're doing for the next 6 to 24 months, is tuning this thing down to get it working here, so that eventually the hope is that we can kick out a report that's going to actually be actionable. And it's very much a top-down methodology from that. You have this really extensive configuration period, but the thing is that was honestly kind of acceptable-ish in the Waterfall world, because if you're releasing every 6 months and it's going to take you 18 months to actually tune your static analysis tool set, like, okay, well, that's 3 releases. Like, that's probably not the end of the world. It just kind of lined up with the timing that we did. So how do we start to adapt this? So really what I've seen be most effective across organizations here. And again, with all of these, there's no one size fits all for everything here. Everything that I'm talking about today is what I've seen be effective across many organizations, which is that we shift from this heavyweight top-down model to a much more bottoms-up model, where we say, okay, rather than we've got this product, we're going to turn it on, and then we're going to make it work. It's we've got this, whether it's commercial product or open source or whatever, it's that what becomes much more effective in the DevOps world is you start small. You start really, really small here. And you say, okay, I'm going to pick one vulnerability class. And so I'm going to say, okay, well, let me pick one here that I'm going to start with that, and I'm going to get that good, and I'm going to have that running in production. So the methodology here is like you take a look at the classes of vulns that you care about most, and you focus on eliminating false positives for that, and then when you hit that goal of only producing real issues that come out of there, then you wire that one up for your build pipeline and for your developers there. And then you go back and you add a second vulnerability class, and then a third vulnerability class. And by starting bottoms up, you're not in this heavyweight model. And this really is what gets you to the actual design goal of effective static analysis in this kind of DevOps agile world, which is that you need to be able to run this on every commit. Right? This can't be, in the old model we would run it, I typically would always see it as like, you run once a week on the build server or something like that, maybe once a month, it'd spit out the report, and then you'd kind of work that in to your sprints. You really want static analysis at high velocity, where it's going on every commit, and you can directly give feedback to your development team and to your security team from that. So an example of that would be, rather than trying to start with all these vulnerability categories, pick one. The one I've always liked to start with is command execution, because it turns out grepping for a system call is really easy and does not typically have many false positives. And so you can kind of build up from there. And the other thing to think about here is that this is not just a technical problem. I'm not going to go into much of the culture stuff, like I said, but there's a huge underlying bit here, which is that static analysis has always been an extremely heavyweight process. When you can start to demonstrate to the development teams that, no, this is actually quick, it can run on every commit, it can give you real issues, it really it shows both the value and the velocity of it. And so starting from the bottom and really building up is the way in which I've seen static analysis adapt really well to the DevOps sort of world. Please.
So, talking about doing the static analysis, so you have an example of it grepping.
Mm-hmm.
Basically, you're writing scripts to start looking for classification. So where's the balance between writing scripts that'll run quick on commits and actually bringing a tool in, a more heavyweight tool?
Yeah, so that's a little bit of slide snarkiness right there. Your question is spot on. So the question was, I talk about grep here, that really applies to scripts and kind of basic things that can run fast, but where's the balance between that and more in-depth static analysis? Is that a fair way to?
Yeah, that's exactly.
Okay, cool. So, and that's spot on, actually, which is that, You want to start with the faster ones and build up towards the more in-depth. There's no like, I'm not gonna say there's a magic number there where you say, oh, well, you get this in-depth or anything like that. Because it's gonna depend on your code base and your organization. What I'd recommend is start small, start with like the script stuff, show real issues, show that it can be done fast, and then go more in depth. And you're gonna hit a point at some point where it's like, yeah, this adds 30 minutes to the build cycle, and the build cycle was 20 minutes before, so that's just unacceptable. We'll run that one asynchronously and out of line. But you'll hit a point where you're absolutely able to get more in depth without a huge trade-off of time or effort from the development team there. So I'd say start small, build up is the short version.
Sort of
Yeah.
follow up on that. Something my organization does with their sprint teams is we have an agreement of definition of done, and that's to pass the static security stuff, which there can't be any criticals, highs.
Yep.
So before it even gets to the security team, they've already taken care of those things.
Awesome. He said they've got a policy where, with their static analysis, you can't really ship with criticals or highs or anything like that. And yeah, that's something that I see in a lot of organizations. I didn't think it was going to be James to walk out on me first. No. I won't name everybody who leaves. Don't worry. You don't have to stay in your seats. Was there another question over here? Did I see something during that time? Okay, cool. Yeah. So I didn't see who actually said that. Yes.
So when you write the command, the scripts basically run, would it be running the whole baseline or just the component will change?
Yeah, so the question was, and I'll make it a little more generic, which is that whatever sort of static analysis that you're doing here, whether it's scripts or more in depth, are you applying that just on the change set, or are you applying that across the code base? Is that, okay. So yeah, when you start out with this, you're always gonna have the backlog, right? If this is the first time you're doing static analysis, you have that backlog of your code base, which is a pretty big backlog usually. What you want to get to is that this is running on every commit. It's running on the change sets so that it's small and fast enough that you can ideally feed it back directly to the developer and say, hey, you just did X here, like that's actually a vuln right there. You can just fix that right within, if this can run within a few minutes of when they check in, they're still in that context, right? They're still thinking about that code and like, oh yeah, I missed this thing, cool, let me fix it. And it's extremely painless for everybody. That's kind of the hallmark of AppSec programs, right? Though is whenever we start, we didn't start on day one, typically. So there is a huge backlog there. That typically gets consumed by the AppSec team, is what I've seen.
Why I asked that question was to piggyback on that question. Because a tool, I don't think would just run for the chips. It would run for the whole baseline. So it would take probably, depending on the number of lines of code,
Yeah.
it might take 2-3 hours. But if you wrote scripts, it would just finish it, run right for that particular code.
Absolutely, yeah. Yeah, so when you first start running it, you're going to consume it as the AppSec team, and then you want to get to a point where your developers can consume it. And that's whether you're doing it as scripts, whether you're doing it as a tool and you're just using certain checks that are essentially scripts. The goal of this is not to really to recommend scripts versus a tool or anything like that. It's just to say, start small, start fast, and show that you can move at the same speed that the development team is moving and build up from there. In Stash or in Jenkins? Where should we have the static analysis? Yeah, the question was where should the static analysis live in the IDE, build, Jenkins, whatever. Honestly, it's going to depend on your organization. What's going to be the most effective? Like where do you put other things? What's kind of the natural place for developers there to get feedback?
Because I think it's better to have it as close to the developer.
Yeah, absolutely. Yeah, in some organizations that works well, and others you're like using Vim as your IDE, and you're not going to plug into that, right? So there's trade-offs there. A couple other things to think about with, I lumped them in static analysis just because it's kind of the most relevant section, but a different take on static analysis. So identifying certain primitives and certain approaches that should initiate conversation with the security team rather than just be blocked. So hashing, encryption, things like that. Specifically, one that's burned me plenty of times in the past here, and that I actually found to be, this is how I learned this lesson actually, was that when you just go mandate, okay, we don't use MD5, we don't use SHA-1, that like breaks the build if you do that, so you need to use SHA-256. What I've actually found to be much more effective there is not the just silent blocking or allowing and being very black and white. It's that, hey, when new code shows up using hashing functions, that should send up a flag to the security team to probably initiate a conversation there. Because I can't tell you the amount of times I've gone to a development team after that and said, hey, I noticed you were writing a bunch of like hashing functions here. What's going on? Like, what are you guys trying to protect? Like, how can I help? And the amount of times that I've then heard back, oh, we're trying to do this. It's like, oh, okay, yeah, hashing doesn't protect you there, right? Like what you want there is encryption, or the reverse, where you see somebody throwing a bunch of AES calls in, and they're just trying to verify integrity or something. They're like, oh, actually, you could just do hashing. It could be a lot lighter weight for you there. So this kind of shift from saying, okay, just the policies. I'm not saying get rid of the policies of saying no MD5 or no SHA-1 or anything there. Those are good policies. But tweaking it a little bit to say, when things like this show up, there's probably something interesting going on there that's probably worth a conversation. And it might be a super fast conversation, which is just, oh yeah, we're doing this. And you're like, great, that's exactly the right use. It might save you a ton of pain down the line when the team is writing a bunch, it turns out they're writing a bunch of their own custom crypto, and you would have never known about that unless you had actually gone and had a conversation. And then kind of final section of the static analysis bit is proactive alerting to know when, in any code base, there's really key controls that are put in there that are almost always write once, change never, right? Like your certain encryption wrappers or authorization primitives, like your role-based access control or something like that. These are the sort of things that you typically write right up front in the app, and then no one ever has to change because it's such a core part of it. Just like with the previous one, you want to know if something changes here, right? Because it might not trigger any of your static analysis or anything like that. But if there's a change to the session management function, something weird is going on there. And if you didn't know about that ahead of time, that becomes a really great conversation starter. Like that is like, hey, why do you change the way that we generate session cookies? Like we should have a conversation on that. Typically, I've tried both ways on this. I've tried blocking on those sort of changes and just alerting. I've personally, and in the organizations I've talked to, found alerting to be much more effective there than actual hard blocking. Because people do make changes, and they make changes for legitimate reasons, but it's infrequent enough that it can drive a conversation. And so I've seen this done in a few ways. Sometimes it's just, it generates an alert to the security team reaches out and says, hey, what's going on? You're messing with session management or something like that. And the team writes back, oh yeah, actually it's just like a white space change in there, it's nothing. I've also seen approaches where it's, you can commit this change, but this is going to alert these 7 tech leads when you do, because this is a sensitive one. And the amount of times that I've then seen developers go like, oh, yeah, actually I didn't need to change that. You don't need to go page our CTO right now. That's totally fine. But if it was an emergency and they needed to change, they could do it. So generating the alerting off of there is something I found to be really effective. The hard blocking is not, because it, more often than not, it just kind of gets in the way there. All right, on to scanning. Science. This is probably one of the quickest sections, actually. So scanning has always typically been as, I've seen it used in kind of 2 ways in organizations. One is just a great baseline, right? Run a scanner. If the scanner finds something, we need to fix that, right? Like anyone's going to be able to find that. Just even if it's a medium or something like that, a scanner found it, like let's get that fixed. Occasionally, you even see it misused as the, oh, we don't need a pen test because we ran Nmap against this, and you're like, I don't. It's why we all have whiskey on our desks. So this kind of changes. I think that dynamic scanning really changes, for me anyway, pretty profoundly, which is that there's kind of a couple things here. Like first, let's step back, which is that when you look at the underlying technology used in modern scanners, commercial, open source, whatever, it really goes back to the early to mid 2000s. And that's not a knock, like that's great. That's when they were really effective. But the way in which we build applications is very different today than we were doing in 2004. And so you see lots of, like client-side functionality and single-page applications and all this sort of stuff that is really, really hard to do as a scanner. It's really hard. And so the way in which scanners, I feel like, can be used effectively, it doesn't go away, it just changes, and we just adapt it. Which is that in the old use case, it was really much more about the dream was very extensive vulnerability discovery, right? That it could figure out our apps, it could crawl enough of it, and it could find lots of good real bugs. Because the apps are getting more complex and changing more frequently and everything there, your best bang for the buck with scanners really changes. That whole in-depth vulnerability discovery honestly goes down quite a lot. But there's two cheap use cases that I really, still to this day, really like scanners for. The first is that ensuring header policies and like security policies that you put in place are actually being deployed there. So being able to say, okay, we've rolled out X frame options, or we are starting to roll out content security policy, or anything like that. We should wire up a scanner that continuously crawls our app and alerts me if I ever see a response that doesn't include one of my security policies here. It's a super cheap way to do it. It's super effective. You're not really going to run into false positives with that. And then the second is actually as a regression test in a lot of ways. We're saying like, okay, in addition to regression testing on the unit test side, this just gives you a nice additional control here where you can say, all right, scanner, log in, go to this page, put script alert 1 in this box, let me know if it ever pops. And so as a regression test like that, I've actually seen a bunch of different things that you'd kind of lump into scanning be really effective there. I am certain I am missing use cases here for organizations that have been really effective. These have been the big two for me. So yeah, like I said, this is probably the shortest section. Questions on that piece? Again, please keep asking them throughout. Yeah, in the back. Oh, good call. Yeah, totally. The point was lumping in cookie handling and TLS and everything like that. That is awesome. That should absolutely be in number 1. Yeah, like you're kind of, would be a good term for that. Yeah, the general response that you're expecting from the application at both the transport layer there and at session level and at certain like headers there, absolutely. That's going in the next revision. Thank you. Yeah. Mm-hmm.
Is it acceptable to use them not in security related way? For example, for file name generation?
Yeah. So the question was, sorry. So I was acknowledging the question first. I realized that sounded like I was saying yes. And that's how you get in trouble. The question was, hashing and everything like that. Is it acceptable to use as file name generation and not just in security contexts? Although in most web apps, I'd say file name generation often is a security context if you're handling like user uploads or something like that. Let me tell you what you typically don't want to do, which is take user-supplied file names for user-generated content. I can tell you those were always the best bugs from the pen testing side is you just go look for any app that has an image uploader or any sort of file uploader, and you pull command execution and directory traversal out of that almost every time. So doing hashing for file name generation, yeah, that's absolutely, that's one way to think about it. I think if I ever stood up on a stage and said, this is the absolute way to do something, that would be terrifying and people should throw things at me. But I will say it is a good one. There was a question further behind there. Yep, nope, all right. Other ones on this section? Cool. All right, visibility up next. If you don't follow honest status pages, by the way, it is painfully accurate if you've worked in web operations. Yeah. That alert exists in probably most organizations. Okay, so the legacy way that we've thought about security visibility, and I would say this is, I say legacy here, but the reality is that this is actually the reality for most of our organizations today, is that the way in which we get visibility is, the problem is that it's extremely siloed, right? You have logs, you have maybe customer support reports, you have outages when things are down, and each source of information was generally very siloed. So maybe ops had access to logs and would grudgingly give some of that to security, but maybe not to developers. Or customer support deals with emails from customers. Like those don't go to engineers. So when somebody writes in and says, hey, my SSL cert is broken with this, like that never actually escalates up to folks. Or outages would page certain people, but not others. So how do we adapt this? It's that the goal becomes, this is really cliche alert, you break down the silos here on this. But this is how you actually start to build effective visibility, is that these isolated data sources that only went to particular teams, that is not effective. Like that should be one of the overwhelming goals of our security groups, is bringing this data together. And so empowering the different teams to all see these data sets and not just like, oh, now I have access to these, but actually bringing them together in a cohesive picture is huge. This is some, yep.
What about compliance
Yeah.
needs to have those separate? And how do you work that in with various compliance structures and say devs cannot have access to production data?
Yeah. I'll repeat it, but yeah, it's in compliance and in regulated industries and all of that. In regulated industries, you just spend half your day crying anyway, dealing with that. It's a technical term. But yeah, how do you deal with the fact that in a lot of cases, you are actually in a real bind with that? What I've seen from the compliance regimes that I've been through on that, it's typically how can we pull at least some aggregate data from that data set. You're not going to be showing credit cards to developers or something, PII to developers, but you're going to show that this sort of event happened or something there, right? So you try to get as detailed as you can get without violating your compliance or your regulatory regimes there, but you really push for that. And the tack I've always taken with auditors there anyway is like, well, you're yelling at me, you want many eyes on this, right? Don't you? Like, you don't want just a single person to be able to make a change there. Like, here we go. People are taking a look. The real thing here is this is not something new that we need to invent as security. This is something that these principles, this is what the whole merging of DevOps, like this is the lesson that the development teams and the DevOps teams had to learn as part of that, which is that you need to bring this sort of operational visibility together, and it's applying that to a security perspective. So I'll give you an example of this, which is that this graph means many different things to many different people. To a developer, it's, oh, the new junior dev on the team probably pushed some bad code and broke the app for a little bit. To an ops team, it's, oh crap, are we down? I just sat down at happy hour. To a security team, it's, are we getting hacked right now, right? It's like somebody finding vulnerabilities right now. And to a pen tester, it's, sweet, I'm finding vulnerabilities right now. The problem is everybody, if they've even had access to that data, that was it. They had it in this very isolated way. And what the future that we're headed towards is the ability to bring in context for everybody here so that you can start to see, okay, because for one of the developer questions there is, yeah, are we getting attacked right now? And being able to overlay that with security data where you can say, okay, no, this is just a bad deploy, or no, we actually are being attacked right now. And bringing it for all groups, that's what we get to. That's the future that we get to that actually enables velocity between these teams. I'm going to talk more about this in a second. Feedback. All right. I'm feeling like Office Space, it's, everything old is new again. Like I feel like we're back to the point where we can bring back some Office Space memes, but maybe it's too soon. Okay, feedback, legacy, it's always been this pen test, right? That's how we've had feedback, is we ran a pen test, we get a report. When you run a pen test once a year, really the only thing that it gives you is, do I have bugs? Spoiler alert, yes. We all have bugs. The answer is always yes. when we only released applications annually or biannually or anything like that, it was kind of real-time enough. Most organizations, it was only the most forward ones that were running many, many pen tests a year. Lots of places were, doing the once a year kind of either as a compliance requirement or something like that. So how do we start to adapt this? And this should actually be just kind of titled more around bounties, which is why I'm really excited about bounties, is that, and I want to be super clear, bounties are not a replacement for a pen test. I really actually feel pretty strongly about this one, and I've been on both sides of the fence of launching bounty programs and being a pen tester and hiring pen testers. They really augment your feedback program. And the value, one of the biggest values in bounties that I see, and there are way better people in the audience here that can talk about bounties than I can, but it's the continuous nature of it, right? It's this much tighter feedback loop. And it gives you, in general, it typically gives you more general, sometimes it can give you really deep, but sometimes shallow, more real-time feedback. And your pen test, what's really nice, why these two are chocolate and peanut butter and go so well together, is that your pen test no longer has to be okay, you've only got a week and scan everything and give me a general report. Your pen test can become this really directed piece that says, here's a new bit of functionality that's not released yet that we really want reviewed before it goes out the door. And your bounty can be like the general sanity check on what's going on there. And you can get really deep stuff out of bounties as well. I've seen spectacular vulnerabilities come out of bounties. So I'm not saying that bounties are shallow by any means. It's that you're able to direct them differently typically, and you can get feedback in different time there. So I was going to try to illustrate this in MS Paint, and it turns out our VP of Marketing strongly disagrees with me on that point, so he made an actual graph, which is that if you do, in terms of coverage and frequency, your scanning and everything like that, it's like we've talked about. It goes to even lower coverage than we had before, but you could wire that thing up to run every 10 seconds if you want. Bounties are like this. Why I'm so excited about bounties is they give this nice coverage in the middle, where they give you a nice amount of frequency, a nice amount of coverage, and they really couple with everything else that you're already doing and augment that so that you get overall, in terms of your program, you get nice coverage out of all of these. Cool, we're headed into the last section. So questions on this? Bounties and feedback? Cool. Yeah.
So can you go into a little more depth about
Yep.
like how pen tests would change for engagement?
Yeah, so the question is, how would pen test change? The shortest answer there, I'd say, is that I've seen a lot of pen tests in the past be kind of all-encompassing, right? Sometimes they're directed at a particular feature or at a particular release or something like that, but a lot of times it's, you come in once a year, do a pen test of the full app, and then drop a report on that. And the problem is you can only get so deep on certain points. I see that Bounty starts to give you a lot of general coverage like that and more real time, and then you use your pen test to say, this is a particular feature that I want you to deep dive only on this. And before, where that was kind of a trade-off for you, because you're like, well, what am I leaving on the table then? Now you're getting coverage between the two spots. And so that's why I really like the rise of the two, as they augment each other. Right? Neither one replaces each other, they augment each other, and they're kind of 1 + 1 = 3 out of that.
So it's a complete scope change.
Yeah. I see that you might still do your pen tests, because you might have a compliance requirement that they go full scope or something there. The most effective ways I see it is that you use pen tests more targeted, and you use Bounty for more coverage. Yeah. Dynamic application scanning stuff. I couldn't fit dynamic scanners in there, so I went with the acronym. Yeah, I left static off of this because this isn't meant to be like a complete overall one. This is just meant to be kind of in terms of testing and direct feedback right there. That's a totally fair question, though. Yeah. Yeah, if you have a $50 million pen test program where you're running one every day, then I'd probably put that up there. What's that? RASP? No, I would not put that there at all. Then again, I'm not Gartner, so I don't make a magic tetrahedron or whatever. Yeah?
How's an application scan different from a pen test?
Depth, quality, right? People versus a script running a thing. Yeah, oh, sorry. The question was, how is a scan different from a pen test? Don't get me wrong, you can hire pen test shops that just hit the button on the scanner. And you can also spend years writing your own custom scanner that's gonna be better than like low-end pen tests. In aggregate, it's that you're having people really deep dive on something versus a tool. Cool. Other questions on this section? All right. Yeah, we're actually getting close on time. Cool. All right. It's time to break out the thought leader hosen and some thoughts on where application security should actually be headed towards. And this is kind of the conclusion section, right? This is really around taking what we've talked about and bringing that together. So I think the hallmark of a modern AppSec program that we should be striving towards, like this is, in my head, this is the goal where we all need to be headed. And where some organizations are already there, others are already on the track, and others are kind of figuring out where they go in this new world. It's this combination of continuous feedback and continuous visibility. And so from the other side of it, and this is really something I feel strongly about as well, is that we as defenders need to spend more time thinking about how we are actually attacked. It's this notion of attack-driven defense, and not just doing it off of the checklists and things like that of walking through every piece of our SDLC. But if you want something really effective too, instead of walking forward through your SDLC as a thought exercise, walk backwards through the attack chain and say, okay, how would I know at this point? 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 And not just how would I know, but how would I actually make that harder for my adversaries? And so the shortest way I could kind of put that together is, how do I know when an attacker actually discovers or starts exploiting vulnerabilities in my application? This is a question that almost every organization today cannot answer to a large degree. And this is really where we want to be focused. We've talk about this in a minute, but we focused a lot on eliminating vulnerabilities in the development cycle, and that's absolutely correct. And I'm certainly not saying we stop doing that. It's quite the opposite. We need more effective ways of doing that, but we need to couple that up with ways of how do we get real visibility here, and how do we empower our development teams to know when attackers are discovering vulns. So I'll give you an example of this in just a second. But I think that the three real pillars of this kind of effective approach are the ability to detect an attacker as early as possible in the attack chain. Right? Work your way back through the attack chain and say, at this given one, and this was a very humbling moment in my career when I first did this, because I'm like, yeah, of course we'd know. And then I worked through it, I'm like, we would have no idea, right? And the more that I ran like realistic attack scenarios and red teams and attack simulations, the more you realize how much this is worth investing in. Yeah.
Just go on, so I've never done like that attack chain.
Okay.
So
Great.
how would someone who's never done that actually start doing that?
Yeah. So I would say that is a great question, and I'm actually super bummed I'm going to give a short answer on that, because I talked for an hour on that one. The question is, how would you, it's great that I talk about the attack chain here, but give a little more practical example of that, right? Like, what would you actually think through? I never plug my own stuff, but I did a different talk on that, pretty in depth. It's called Attack-Driven Defense. It's up on SlideShare if you want to take it more in depth. The short version is you take a look from exfiltration, so I'm doing this backwards, so I'll mess it up. Exfiltration, command and control, lateral movement, vulnerability discovery, initial recon, and you work backwards through those steps and you say, if someone was at this step of exfiltrating my database, how would I know? If someone was at this step of moving from my web server that they popped with a command execution to a database, how would I know? If they were at this point of discovering the command execution, how would I know? And you want to work your way back. Typically, it gets a little harder as you get more towards the beginning. But I'd really say that think about that as the thought exercise of these particular points. If anyone wants to talk more on that one, drop me an email afterwards. That's a conversation for an hour easily, but a really good one, I feel like. Please.
In that thought exercise, if you find it difficult to ask the question about my app, because of course my app is perfect, instead ask, how would the infrastructure help me to know?
Yes.
And after each time you hear they can't, or it would cost a lot of money or whatever, you then have the right approach to be able to
Yeah. And a lot of times it doesn't cost a lot of money, actually. But I completely agree with everything you said there. Yeah. Thank you. And your goal really becomes, just like it's kind of the flip of the SDLC, right? Which is where we've always focused on how do we catch bugs better earlier? That's absolutely still true. How do we catch attackers better and earlier? And we tend to work from kind of opposite sides on that. The ability, so number 2, the ability to continuously test and refine your vulnerability triage and response. The first time that if you launch a bug bounty, the first report that comes in is going to be a dumpster fire inside your organization. Like it is going to be, because you're not going to know who to talk to, like everyone's going to get paged on that. Like it's hard. It's hard. The bug bounty companies are really cool and they help with so much of that. And I really believe in them, but it's still, at a certain point, it's still on you and your organization to figure out, okay, who actually owns that line of code that was written 8 years ago and the developer left 5 years ago and that team got disbanded 3 years ago. How do I actually work through that? It's good. Like that is the type of exercise that you want in your application security program. Because when one comes in on day 1, it's a nightmare. When one comes in 8 months from now, you're like, yeah, we got this, it's no problem. Like we know who to talk to, we know how to triage, your hair's not on fire anymore. It's a really good exercise to go through. And the beauty of it, Dan Kaminsky says this way better than I do. So I'm gonna butcher it in this quote, but it's that the beauty of DevOps is that for the first time as defenders, we can actually move faster than our adversaries. Like that is amazing. This is why I completely drink the Kool-Aid, even as a jaded security person, about DevOps and CI/CD and everything here is that, yeah, there's plenty of things we can mess up with it, just like anything else. But the reality is, for our first time in our defensive programs, we could actually move faster than our adversaries. We have the raw ingredients to do it, and we can actually change the game on them. And I will show you that in just a second, actually. The third pillar is that, similar to the second was really about being able to triage bugs and work with teams on that and fix them yourselves. The third is that your SecOps or data forensics, DFIR, incident response, anything like that, you get if the only time that you're doing that is when you have a real incident, like you're in trouble, right? It's just like fixing bugs, right? If the only time you ever try to fix a bug is when production is down, you are in a world of pain. But if you're able to run this exercise continuously and say, okay, well, even when a really great researcher just reported a bug to us and they were really friendly to deal with and it was a great experience, let's run this as if they hadn't been. Let's run this as if it was an attacker who discovered a vuln, and let's run that process to be able to try to answer questions like, was there something that they found that they didn't tell us? Was that bug that they found us actually, or that they reported to us, actually previously exploited? We're on camera, but I'll share this vaguely anyway. At one point in my career, one of the scariest things that I've ever seen as a defender was we got to this point in visibility. I've actually seen cases where attackers discovered vulns. I knew that they had discovered them. It wasn't just like a scanner. Like we watched them figure out that they had a bug, and then they just went away. And they never reported it, and they never started exploiting it right there. That was one of the most terrifying moments in my AppSec career. Because it's like, okay, yeah, you're saving that for something. And that's not gonna be a good day whenever that something is. But thankfully, we were at the point where we knew that and we just changed the game out from under them and we fixed that bug. So being able to run these as actual mini incidents, you just really level up your program like this. You have this great data set, use it. So the example that I'll give here, and there've actually been a bunch recently with Signal Sciences, but I want to be able to actually name drop like the company there. So I used an example from my time at Etsy, which is that this was from a Reddit NetSec post a couple years ago, where this really awesome researcher did this post in Reddit NetSec. And the gist of it was that they found a vuln, and then we actually detected that, and we pushed a fix before they reported it. So they ended up writing in and saying like, hey, this suspiciously does not work anymore when it did 24 hours ago. By the way, I was testing from my home IP, don't sue me, and I was totally gonna report it. We kind of went, neck and neck there. But it actually was it turned out to be a really great interaction with this researcher, and they wrote up the whole thing on there. But it was not because like, oh, we're so cool that we detected this or something like that. It's that these principles actually work, right? When you can get to this is why I feel so strongly about what I'm talking about here of this is the future of where we're taking our AppSec programs together, is that you can get to this point where we can actually win against adversaries here. So that was the upbeat, aside from my normal sarcastic things, that was the upbeat tone I kind of wanted to leave you with. And the closing thesis there is really that the thesis of modern application security, as we really think about the future of how we push our programs forward, is that we go from this shift of exclusively focusing on gatekeeping controls to eliminate bugs before code is deployed. The problem is this has a really strong parallel to the way we used to approach phishing, which is that with phishing, we used to always do the security awareness training and try to get people to not click on links. Guess what? People click on links. Like, it's human nature. You're never going to get the amount of people that click on links to go to zero. So the most effective phishing programs in the world now, or counter phishing programs, I guess, are not the ones that focus exclusively on that. They're the ones that couple that with focusing on reporting phishing when you get one, right? So letting the security team know. It's that same sort of principle in how we have to fundamentally change AppSec, which is we can't just focus on trying to get bugs to zero. It's never going to happen. It doesn't mean we stop doing it. In fact, we need better ways of doing it, and we absolutely need to focus on it, but it can't be the exclusive model. What we need to couple that with is focusing on getting continuous visibility and feedback and providing those security capabilities to our development teams, to our DevOps teams, so that they can be security self-sufficient, because that's how you actually enable velocity. And so you're all awesome. Thank you for coming. Question, yeah, I think we've got, we got like 7 minutes for questions.
How important is the dev training and the threat modeling?
Yep, the question was, how important is dev training and threat modeling in security? I would say that's absolutely one of the ones that is important, but I cut it out of here in the span of time. And so that was not a slight on any of those. I still agree with dev training and with threat modeling. I've done plenty of threat modeling, yeah. Please. Yeah. The question was, do you have a suggestion on like a big data system or the way in which you start to collect that data and aggregate it and get that visibility? The bias caveat here is that's a lot of what my company actually does, is make a product on that. But there are a lot of open source ways that you can think about that, of getting data into Splunk or Elk or anything like that. It's hard. It's hard. Like, I've done that in the past. It's hard. It's why we built what we built. Yeah. Please.
That stack that you explained of like where an industry is building an app, you said like there's more information you have.
Yeah.
When can I get some more information?
On the